Have you ever wondered if we as humans are the real aliens on this planet? A thought-provoking question, isn't it? It challenges our conventional understanding of human origins and nudges us to consider Earth as merely a host planet for human life. Imagine for a moment that we didn't evolve here, but instead we arrived from some distant corner of the cosmos. This might sound like a science fiction plot, but several theories suggest that it may be closer to reality than we think. One strong supporter of this alien hypothesis is the panspermia theory. Panspermia is a Greek term that translates to seeds everywhere. It's an age-old theory that suggests life on our planet may have been seeded from elsewhere in the universe. This theory challenges the traditional belief that life originated on Earth, proposing instead that life, or the building blocks of life, were transported to Earth from far-off cosmic bodies. This transportation could have occurred in several ways. One proposed method is lithopanspermia, where life travels on rocks ejected from a planet's surface after a significant impact like an asteroid collision. These rocks, carrying microorganisms or life-bearing compounds, could then travel through space and land on another planet, potentially seeding new life. Another method could be radiopanspermia, where life's building blocks like DNA, RNA, or amino acids are pushed across the universe by radiation pressure. These life-bearing molecules could then potentially form life when they reach a suitable environment like Earth. But how do these life forms survive the journey through the harsh and unforgiving vacuum of space? Well, it's believed that these organisms or genetic materials could be protected within the rock or encased in icy comets, shielding them from radiation and allowing them to endure the extreme temperatures and pressures of space. Comets in particular have been of interest to panspermia theorists. These icy celestial bodies are seen as cosmic delivery systems, carrying a rich cocktail of organic compounds. Some scientists believe that the impact of these comets could have delivered the necessary ingredients for life to our planet billions of years ago. But the panspermia theory is not without its skeptics. It raises as many questions as it seeks to answer. For instance, where did the original life forms or genetic materials come from? Panspermia only shifts the origin of life question to another location in the universe. Yet, if panspermia holds true, then we could all be descendants of extraterrestrial life. It's an idea that challenges our understanding of life's origins and our place in the cosmos. We may not be alone. In fact, we may be more connected to the universe than we ever imagined. If panspermia holds true, then we could all be descendants of extraterrestrial life. Our own genetic code might be hiding clues about our alien ancestry. If you find that hard to believe, brace yourself for a dive into the deep and complex world of the human genome. The human genome, the complete set of our DNA, including all of our genes, it's a marvel of nature. It's a complex and intricate blueprint that guides the growth, development, functioning, and reproduction of every cell in our bodies. This complexity is so vast, it's almost alien in its nature, leading some to ponder whether our origins might stretch beyond the confines of this planet. Now let's delve into the enigma of junk DNA. This term refers to the portions of our DNA that do not encode for protein sequences. An astounding 98% of our genetic material falls into this category. For years, scientists dismissed this as evolutionary clutter, but recently perspectives have begun to shift. Some scientists propose that this junk DNA might not be junk at all. Instead, it could be a cosmic calling card, a sign of extraterrestrial influence on our genetic makeup. They argue that the complexity of this junk DNA might be too great to have originated solely on Earth. Research in this field is still in its infancy, and there's a long way to go before we have any definitive answers. However, the question remains tantalizing. Could our own DNA hold the answers to our potentially celestial lineage? The mysteries surrounding our genetic code are vast and deep, like the cosmos itself. While we're still far from understanding the full extent of our genome's complexities, we're making strides in unraveling the secrets it holds. Every new discovery brings us a step closer to understanding who we are and where we come from. Remember, as we explore the cosmos, we must also explore ourselves. Our bodies are galaxies unto themselves, filled with mysteries waiting to be discovered. Our DNA might be the key to proving our alien heritage. So keep an open mind, for the next breakthrough might just redefine our understanding of our place in the universe. The Drake equation, a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy, might also support our alien origins. The Drake equation, named after astronomer Frank Drake, is a tool for pondering the vastness of our galaxy and the potential for life beyond Earth. It's a formula that considers factors like the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. It's a mathematical expression of the variables needed for a technologically advanced civilization to exist. And when you crunch the numbers, even with conservative estimates, the equation suggests a high probability of extraterrestrial life. Some scientists even theorize that the number could be in the millions. So if there's a high likelihood of life beyond Earth, could we humans have originated from these distant civilizations? It's a provocative idea, isn't it? If life can start and evolve on other planets, why not have it transported to Earth through methods like panspermia, as we discussed earlier? That's the intriguing implication of the Drake equation. It doesn't just suggest the existence of alien life, it opens up the possibility that we ourselves might be the descendants of that life. Perhaps we're not just inhabitants of Earth, but children of the cosmos. The Drake equation suggests we may not be alone in the universe, and we might even be the offspring of these distant civilizations. So, are we the real aliens on planet Earth? We've embarked on a journey today exploring the possibility that we humans may not be as native to this planet as we've always believed. We've dived into the captivating panspermia theory, which suggests that life on Earth could have originated from microscopic organisms or biochemical compounds from outer space. We've probed into the enigmatic human genome, unraveling its mysteries and questioning the origins of our unique genetic makeup. And we've grappled with the implications of the Drake equation, a mathematical formula that estimates the number of civilizations in the cosmos with which we could communicate. Each of these points paints a compelling picture, nudging us to reconsider our place in the cosmic order. Whether we are or aren't, one thing is certain. Contemplating our origins and place in the universe is a fascinating journey, one that may redefine our understanding of what it means to be human.